Good afternoon, and once again, welcome to my YouTube channel, whereby we have been explaining uh, pure Edexcel Pearson Edexcel International Advanced Level Mathematics. And here we will be dealing with Pure Mathematics Book 3, or rather Pure 3, and we'll be introducing the fifth chapter. Which we are calling exponentials and logarithms. Please visit my YouTube channel that is called Pearson Edexcel Mathematics, or rather Pearson Edexcel Maths by Mr. Kamotho, and you will find me there. Follow me, share, and like. And today I want us to just understand something to do with exponentials and logarithm. And I'll be introducing chapter 5, which is on page 102, exponentials and logarithms. And to introduce this, I would want to say that the function of which looks like fxa raised to power x, where a is a constant. These are called exponential. They are called exponential functions. They are called exponential functions due to the fact that the index, or rather the variable, is at the index position, and this variable, you can call it index. X can be called, it is actually the index. Some books we call it the power, but in this particular topic we will call it exponent. We'll call it exponent. Exponent, or rather exponential functions, are functions that have uncontrollable growth or decay. We will see exactly what happens and the reason why they are called exponential functions. For example, if you have a function like y is equals 2 raised to power x, as illustrated on page 103, it is important to just have x here and y here. And before we can even go to y, okay, let's have y. Let's have the evaluation. Let's have the evaluation, and then let's bring the y. I'll tell you what we may be having in the evaluation. And at this particular point, when we have y is equals to 2 raised to power x, when x happens to be negative 3, then we are going to have 2 raised to power negative 3. Everybody knows that 2 raised to power negative 3 is equals to 1 over 2 raised to power 3, which is basically 1 over 8. And that is why we've brought the evaluation. And when x is negative 2, then we have 2 raised to power negative 2, which is 1 over 2 raised to power 2, 1 over 2 raised to power 2, which is a quarter. When x is negative 1, we are having 1 over 2 raised to power positive 1, which is a half. When x is a 0, and it is important that everybody pays attention here, any number raised to power 0 is obviously 1. We are talking about 2 raised to power 0 is not different, it's just 1. So when x is 1, 2 raised to power 1 is now 2. When x is 2, 2 raised to power 2 is a 4. When x is a 3, 2 raised to power 3 is an 8. And of course, our general kind of graph looks something like this. So you will talk of, as x continues to be greater negative numbers, then the value of y approaches 0. It will never touch 0, but you can see it approaches 0. But of most importance, I would want to let you know that every graph of exponential, if it is not transformed, if it has not undergone any transformation, it is a must that it passes through point 0, 1. This is point 0, 1. And you can see it over here. When x is 0, then y is equals to 1. You can see at some point as x continues to be a bigger positive number, then you can see the y continues to be larger, to be a very big number. So we are assuming sometimes x can even be 10. Let's say when x is equals to 10, and let's talk about that so that we can actually understand the exponential. You can see 2 raised to power 10 is going to give us 1024. So if you may talk about this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, and 10. If you just talk about it is very easy to reach 10 along the x-axis, very easy to reach 10, but along the y-axis we want to go until we get to 1024. Such is a very big number, considering that when x was 2, this was simply a 4. This is coordinates 2, 4, because 2 squared is 4. But of course you can see as x is 10, it is very easy to reach 10 along the x-axis. But of course you can see under normal graph it is difficult to reach 1024 in this scale, whereby we are having 1 here, we are having 2 here. It is practically impossible to reach 1024, and that is why you can already see that it reached a time and the values of y shot. They shot rapidly, and of course they became uncontrollable. Of course it is not easy to plot 1024 in a normal graph paper, and that is why these graphs are called exponential graph. The other meaning of the word exponential, probably in English form, we could talk about uncontrollable behavior, which is an uncontrollable increase or uncontrollable decrease. This kind of functions are the ones which explain decay in science or growth even in biology or anything else, but we shall see them in details as we get to video number 2. Yes, this is just an introduction of what we expect in this particular topic. And again, I repeat, yes, visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Subscribe, yes, share, and yes, like it. You will walk the journey of understanding mathematics together. All right?